So guys, today I'm going to explain about the YDSE, Young's double slit experiment. It's an important topic in physics for IIT. So for this experiment, let us understand the setup. The setup is like this. This thing we call it as D, the distance between the screen and the width. And this thing is small d, distance between the two slits is small d. And what happens is light enters from such source to this to these splits, and the further path of the light is, say for example, this meets at point B. This distance traveled by the light is x1 and this distance x1, so their path difference is 0, and this becomes central maxima central maxima as delta x is 0. Delta x is basically the distance traveled by the lights. The difference between the distance traveled by the lights is delta x. And here let us understand the basic information about the intensity and amplitude. From SHM we have studied a net equals to under root a1 square plus a2 square plus 2 a1 a2 cos delta phi. And we also know that a is proportional to I square, so I net becomes I1 plus I2 plus under root I1 I2 cos delta phi. Delta phi is basically the phase difference So from the previous formula, you might ask me what is cos delta phi. So delta phi, the value of delta phi is k delta x, where delta x is path difference. Delta phi equals to the value of k is 2 pi by lambda and delta x as it is. This formula is important. Let us understand the formula of I net. I net equals to I max into cos square delta phi by 2. This is an important formula to learn. So you might ask me what is this I max. So let us understand. I max is under root I max is under root I1 plus under root I2 whole square, and I minimum is under root I1 minus under root I2 whole square. If I1 equals to I2 equals to I naught, then what is I max? Many of the questions they ask the ratios of I max upon I minimum. So see if I1 I2 are same and equals to I naught, so it becomes 2 under root I naught upon So from here you'll get the formula of I max and I minimum. So if you subtract them, you get 0. I minimum is 0. So now let's understand what is delta x. So here I have made the setup of YDSE, where this is the split, this is the split, and the distance between the two splits is small d, and the distance between the screen and the splits is capital D. Capital D is much more than small d. This you have to assume. What happens? For example, the light here travels distance x1, and here the distance x2, for example. And you know that now you can tell me the first line or the second line which have traveled the more paths. So you can see the second line had traveled the more path. So you can make a perpendicular from here, and you can say the point AB is same as the point A prime B. The distance between AB is same as the distance of A prime and B, and you make a perpendicular over here. So let us assume this angle theta. Also this angle is theta. To assume like this. So this angle is theta, and this distance is y distance. And now you can say this angle is also theta. So you can say sine theta is almost equals to tan theta, and tan theta equals to y by d. Okay. And path difference equals to d sine theta, and sine theta almost equals to tan theta equals to y by d. Dy by d delta x equals to dy by d, and also delta x equals to n lambda if it is a maximum interference. Let me elaborate this point over here. Maximum interference and minimum interference. For maximum interference, delta x equals to n lambda, where n can be 0, 1, 2, anything. And for minimum interference, delta x equals to n minus half lambda, where n can be 1, 2, 3. Note here it should not be 0. And minimum interference, it means that there is a dark fringe, and for maximum interference there is a light fringe. You have to remember these two formulas. From here we can say delta x equals to d sine theta, delta x equals to n lambda. So if you solve the questions, you can write n lambda equals to d sine theta, and equals to n lambda equals to d sine theta you got over here y by d, and lambda equals to dy by d and n. So this you can use it for question practice. And let me show you the next thing. If we add a film over here, what happens? Let me show that. So let me tell you, if you have a film in the YDSE experiment, the film length is t, and it is in a mu medium of value mu. What happens in air? It travels t. Suppose this is air where mu equals to 1. This is t. Okay. So the light travels in air is t, but in any medium it travels mu t. this concept you have to remember. In any medium, light travels mu t, and in air, light travels t. You can see v equals to c by mu, like that also logic you can use. So you have to remember it travels more than air. In any medium you have a film, it travels more than the light which traveled in air. This you have to remember. So let us see here what happens. This light is this, and this is this, for example. So tell me, this line travel more or this line travel more? Oh, of course this is t and in a medium mu. So this light travels more, and if further I have to show this, because in this it travels mu t, and here in the medium is air only, mu equals to 1. So it travels t. It travels t distance here and it travels mu t. So altogether the line this travels more. So it becomes like this. Due to this film of t in a medium mu, the light ray becomes like this. To cover up the distance, we have to make light to travel the more. Okay. So this is the thing. One more thing I want to tell you. Suppose this is the experiment about the intensity. This is the distance d. This is capital D. So if light ray converges here, making the path difference 0, it has a central maxima, and the intensity becomes 4 I naught. Then again there is a dark fringe, then a bright fringe of intensity 4 I naught. The dark fringe intensity is 0. You saw it before. Again 0, then again 4 I naught. Like this it continues. And by calculating the path difference, delta x equals to d sine theta. Okay, delta x equals to d sine theta was y by d. Suppose I want to calculate till n equals to 1, so this is y by d, and n equals to 1, we have the data y equals to y into d by d equals to n lambda. N equals to 1, so 1 into lambda. So y becomes lambda d by d for n equals to 1. So this distance we have got lambda d by d, so we'll write lambda d by d. Like this, if you do for n equals to 2, it becomes 2 lambda d by d. Sorry, 2 lambda d by small d. Like this you start getting. Okay. And one more thing I want to tell you, the distance between the two bright fringes or the dark fringes is known as beta. Beta is basically fringe width. Sorry, not fringe width. The distance between the two, yeah, fringe width. Fringe width. So this is beta. Okay. So beta equals to, suppose we take this 2 lambda d by d minus lambda d by d, it becomes lambda d by d. So you have to remember the formula of beta as this. And one more thing I want to tell you, this is beta equals to lambda d by d. This is basically, suppose let us consider the difference between these two, center maxima and first maxima. This is beta and this is theta and this is d. So you know this angle is very small, so beta equals to theta d. Beta equals to theta into d. So theta is basically angular fringe width. So angular fringe width is basically beta by capital D. So if you do beta by capital D, it becomes lambda by D. Theta equals to lambda by D. This also sometimes they ask. One more thing, last thing I want to tell you, sometimes they might give you only the width. Width means this, the width of the, this thing is width. So sometimes they give you width. You must understand width is proportional to I. This is a very important thing. So this was all about YDSE. Thank you, hope you understand. Subscribe.